Hello, everyone, and welcome to this talk today about how to modernize an old legacy .NET Framework application to .NET Core. Happy to have you all here. I hope you're in the right room. I'm going to be fun to have you here for 45 minutes and discuss this topic. If you have any questions during the talk, please feel free to put them in the Q&A and chat here. Happy to get to them at the end. I'll try to get to those that make sense during the talk, but mostly we'll sum it up at the end here as well. So to kick off first, a little bit about myself here. I am based out of Washington, D.C. The reason why my room sounds so empty is because I'm relocating to North Carolina, but I work for a company called Excella that's DC-based. I just love .NET. I love machine learning, and I spend a lot of my time working in the .NET and machine learning community. I'm also a Microsoft MVP on the time here on the side, so I speak a lot, I write some blog posts, and I create software through open source solutions. So if you are interested in me later, definitely check me out on my profiles. Happy to connect either on LinkedIn or Twitter. But today, right, we are here to talk about some really fun topics. And we are here to talk about a year-long journey I had with my team at a client site in the middle of the pandemic during 2020. And I want to talk a bit more about how we actually went from getting the buy-in and talk to the organization to get one of their larger .NET Framework monoliths to .NET Core, which took about a year's time for us with many years preparation. Because I see a lot of talks out there right now of how to actually get to .NET Core, what .NET Core is, but not so many case studies on how it actually kind of happened during a year's time. So I hope you find it useful. But we'll start off talking about the organization and the app bits. We'll move on to the actual content here, what kind of technical things you need to think about, what kind of tripwire we run into, and so forth. And then we'll sum up with some lessons learned on what I would have done differently if I would have done this again. So let's start with the app. The app is a very standard .NET Framework monolith, I would say. It's large, it has a API layer, it has a domain layer and database layer. It uses Entity Framework to talk to SQL Server, and it's very large. It has like 20 plus projects, tons of old dependencies of different sizes and importance. And it has a standalone front end that is done in AngularJS and Nokia.js. So it's kind of standard old .NET Framework app, I would say. The difference with this app is that it's highly connected with everything else in the organization. So it has its own UI, of course, but it also serves as kind of the master hub for data and other connectivity. So we have other glue applications like Node.js applications and messaging services like RabbitMQ and BizTalk integrations and so forth that talks to this application. So we had to make sure that when we changed this application and modernized it, we didn't break any other dependencies as we moved along. And that was really important for our client as we kind of set out to do this. The organization as a whole, though, of course, matters when you do something like this because depending on organization, you'll have an easier time getting buy-in, easier time getting kind of work done at the same time, and so forth. In our case here, the client we were working with was kind of a waterfall agile organization, as I would call them. They had their sprint teams and their scrum teams, and they worked in 2-week sprint, and that was all good. But the rest of the organization was highly, highly waterfall. They had long, many-year projects. They didn't really have a product mindset. They were very highly risk adverse, so experimentation was pretty low. They didn't really care too much about staying up on the latest, as you can tell from AngularJS and Nokia.js, and they rather just wanted to leave things as they were. So we had to kind of start changing the culture as well of, yes, it's important to stay up with the latest, because otherwise you incur all this technical depth that you have to pay off later. But the good thing with this organization, though, is that we had a fantastic team, a great mix of BAs, developers, and QAs, all very accountable and committed to doing high quality work. So, like any good story, right, it starts with getting the buy-in. Who wants to actually pay for doing this? And we had tried many times over many years to get this buy-in, and we had failed miserably each time. And that was a hard kind of sell for us to get this organization to really want to go with this approach. And I think a couple of arguments that I would just point out as selling arguments in case you want to do this within your organization is that going to .NET Core 3.1 for us was important because they had long-term support. And the client actually ended up going to .NET 5 directly after we went there, but that's another story. But for us, some winning arguments was really around security. And you've seen a lot of these cyber attacks lately, right? You've had one in the US where I'm based, here for Colonial Pipelines, just a month ago, I guess. And you've seen that across the world over the last few years, that it's important to also stay up with your security patches. And a buy-in to doing this is that, hey, you can have updated dependencies. If a dependency is a vulnerability, you can update directly because you're already compatible with whatever that needs to happen. And of course, you go to containers, then you have an easier time updating your patching your kind of operating systems and so forth. So it just makes a lot of sense. And for us also, the client really wanted to go to the cloud. They were on-premise, they paid a lot of money for their local kind of server housing. So for us, this was the way to go to the cloud. Because by going to .NET Core, they were able to containerize, put that in Kubernetes, then move that Kubernetes cluster into AWS, etc., etc. So that really extended a lifetime application, as well as gave them a path forward to that. And that's, I would say, actually, it's one of the biggest arguments I use to new clients as well, is saying, hey, if you want to go to the cloud without just doing a lift and shift, this is something you need to do. Otherwise, you won't get there. So how do we get there? Where do we start? Well, like any other good developer, right? I Googled this. And the first thing you end up with is Microsoft documentations. And they're fantastic. There's, I think, 2 different kinds of documentations for this. But if you look closely here, it's a 7-minute read. And 7 minutes is not going to cover everything for your application. It's a very standard documentation outlining the basic steps for you to get there, but it doesn't take into consideration like specific things for specific parts of your application. Whether you're integrating with WCF, whether you're doing a desktop app, whether you have BizTalk dependencies that needs to go in at the same time, etc., etc. So definitely read through it, but take it with a grain of salt. And one thing I would also mention here is that they do recommend you look at this .NET Portability Analyzer, which basically is a right-click in a solution, and it will spit out an Excel file with like 1,000 lines of things that are incompatible. You can definitely look at it. I did. I wouldn't recommend it though. It's just overwhelming, and it just tells you what's wrong and not how to fix it. So if you kind of want to use that as your driving force, that's going to be difficult, I think. I would rather take some of the steps in this position today, as well as in other documentation online, as your guiding star as you kind of move along this migration effort. All right. So what kind of steps did we take here? So these are the general steps we took to migrate our application. And I'm going to walk through each of them more in detail today to give you an idea of what they entail. But I want to start off to say that we are not going to cover WCF services or web forms, because this application that I modernized did not have neither of those. We did consume WCF services. I want to mention that. We did have endpoints that we consumed, but we didn't actually host WCF services. And that's an important distinction, because you can still consume WCF services in 99% of the cases from your .NET Core client. You just can't host them yourself. And if you have them, you probably want to start looking at going to something like gRPC instead. Maybe you want to modernize them to REST client instead, or something like that. If you want to go to gRPC, just remember that both your service as well as your consumer client needs to be talking into gRPC. So otherwise it won't work. If you're struggling with web forms in your UI, definitely talk to someone like Jeff Fritz here in the US. You can follow him on Twitter. He's also done some great documentation and streaming on Twitch, but he has some great content on how to kind of more or less lift and shift, modernize web forms to Blazor through some cool components. So if you're struggling with that, there are definitely things out there for you to help. So let's start talking about going to .NET 4.7.2. Why do you want to do that? Well, for us, we were on .NET 4.6.1, I think, or something like that. So the first thing we wanted to do was go to .NET 4.7.2. And the reason behind this is because .NET 4.7.2 and .NET Core 3.1, they both share the .NET Standard 2.0 API, which means that they are closest together of like the framework version and the .NET Core version in terms of common API functionality. Some people may say, hey, there's a 4.8 out there, why did we go there? It's because it actually doesn't bring you any closer to .NET Core. It may actually be trickier to get there. So 4.7.2 is a good start. And I want to prefix this discussion actually with something I forgot to mention, is that when we did this modernization with this client, we actually couldn't have a feature freeze for our client. So we couldn't have a long-running branch, we couldn't have stop doing feature development. We had to continuously deliver features to our business users as we modernized in place. And that was a major constraint for us, because that means we actually had to do all these updates in the project and then release them to production every 2 weeks as part of our normal kind of sprint cycle. So we couldn't have anything that was breaking all the time. So we had to do this bit by bit in piecemeal, which I think worked really well, but it definitely is a challenge. But so when you went to 4.7.2, the second thing you want to do here is start looking at your product files. You will probably have like a package.config for your NuGet packages. You want to make sure you migrate that to package references syntax, which basically is taking that package.config, putting that into your project file. You can do this manually or you can do it automatically. I recommend doing it manually, because that gives you the chance to actually clean up a lot of these packages that you may actually not need anymore. And then the final thing here as well I want to mention is that the SDK product style is really important. So right now, if you have an old application, you double click on it and it will basically not open. You have to unload it and you have to edit the product file. But SDK product style is actually much smarter. You can double click on it. It's much more condensed. You don't need to define the classes that are included in the project. It's just everything in the directory are included. And it's just much cleaner. And it's actually not linked to .NET 4.7.2 or to .NET Core. The SDK product style is what you can do as long as you have, I think, Visual Studio 2019 or 18 or 17, I think. That should be able to do it by just using that. So that's definitely a thing to do. So basically what you want to do here is you want to take this old package.config and you want to massage it and you want to put it in something like this into a nice SDK product style format, where you can see you have your definition of what the target framework is, you have your package references and your product references in a very neat format, but you do not have any classes or anything else defined what's included. Cool. So once you have done your 4.7.2 upgrade, which can take up to a month or two actually, depending on your application and complexity. For us, it took actually a month because we had lots of redirect issues and other stuff that happened. But once you've done that, you want to start tackling your configuration in your application. And all applications in .NET Framework really has this XML-based web.config configuration, right? Where you have a setting and you have a value. And what you want to take it to is this app settings.json file instead. Very similar, it's just a JSON format. And you have sections. So we have like a feature section. And within the feature section, we have enable features 1 as a key with a value and so forth. So this is something that you will have to do, and it is actually more complicated than one may think. At least it was much more complicated than we thought. So what you probably want to do here is you want to read both your old web configs and your new app settings JSON at the same time, and then kind of merge an image of those as you kind of slowly phase out your web config. If you have very small web config, small settings, quick and easy, just get it out, do it. But if you are like us, for like a 10-year-old application, big application, we had like 200 different app settings that we had to merge over. And we had to make sure that we coordinated changes into those names in our CI/CD pipelines as well. So we actually overwrite the right values, right secrets, so forth, when we build the application. And it gets a little complicated real quick here. But for us, it was just very good to go ahead and read from both sources at the same time as we phase it out. And in the interest of time here, I'm just going to point you to a blog post here on my blog. I have written a whole blog post on this specific scenario here. My blog post is, on my website is called alexanderslotte.com. And you can find, I think, one of the first ones there. So if you're curious more about this topic, get some code samples on the actual approach to write this custom provider, and how to actually kind of massage your way out of the XML world to a more JSON world, check this out. I think it's been very helpful for others, and I think it will summarize this topic better than I can do it in this talk. But also you can definitely chat me out afterwards, and I'm happy to give you some thoughts. So once you are actually out of this kind of configuration world in old XML, you want to move over to the next step here, which is going to be your dependency updates. And this is, together with a web app, this is really where you will spend the majority of your time doing this migration. But it's also one of the more rewarding things, I think. So think about it from a standpoint that you have your web API and you have all these dependent projects underneath it that supports this web API. And currently what you want to do with dependency updates is that you want to make sure that all your dependencies to those non-web apps get updated and refreshed. And basically what you want to do is you want to go over every NuGet package you have, and you want to find a version of that NuGet package that target .NET Standard 2.0 or below. And basically, if you go to NuGet.com or org, I think, you can actually see something like this. So for example, here's AutoMapper. And you can see here clearly that it has no dependencies for the framework version, but this AutoMapper 10.1.1, it supports .NET Standard 2.0. So this is great. For example, we had we had AutoMapper 3.0 when we started, and it did not support .NET Standard. It only supported .NET Framework versions. So we had to go all the way to 10 here, or actually we could have gone later if you wanted to. We could have gone to like 8 or 9, I think. But you can go to whatever version you're comfortable with that supports .NET Standard 2.0. As you do this, of course, you will notice that you have breaking API changes because the application or the tools you're using have obviously changed. So I recommend creating like a Jira ticket or whatever tool you're using for issue tracking for each one of these packages that you want to update. So if you're going to do AutoMapper, let's do a ticket for that. If you want to do AutoFac or other DI frameworks, do a ticket for that. And slowly kind of massage your way out of this, because each package will have some complexity in it, either breaking API changes or behavior changes or something else that you will need to focus on and make sure you have tests running against. So as you kind of move along and update your packages, you also want to consider enabling something like multi-framework targeting or targeting .NET Standard 2.0 directly. And the way you do that is basically in your property group here, it has this target frameworks with an S on it as well. And you can actually add a list here of frameworks you want to build against when the application builds. And what we decided to do was we wanted .NET Core 3.1 as well as .NET 4.7.2. And the reason behind this is that we wanted to continuously build our production version on .NET 4.7.2 and put that in production every 2 weeks. But we also wanted to have duplicate CI pipelines to build .NET Core 3.1 so we can see kind of how far away from our goal we are and understand what packages are incompatible and what's not working and so forth. Some people may say, hey, you could also just go .NET Standard 2.0, right? That should be fine if you don't actually require things from .NET Core 3.1. And the issue with us is that we did actually require dependencies in .NET Core 3.1, which is why we had to have both of these. And the dependency we had an issue with was actually Entity Framework, and I'll revisit this a bit later. But Entity Framework 6.4, the old Entity Framework 6.4, actually works with .NET Core 3.1. It's compiled against .NET Standard 2.0, which means it works with .NET Core 3.1. So we decided not to upgrade Entity Framework to EF Core and instead stick with the old EF 6.4 because that would reduce the burden on this migration and make it a lot safer for us to do. And I highly recommend this approach if you have the chance to do so and take the EF updates separately, because it's going to be a lot more difficult and risky than what you want to do at the same time here. For example, we had like 400 different entities, and all of their mapping maps had changed, so it would just be a lot to take on to get that working. But if you go ahead and do multi-framework targeting, you also want to do here is conditional dependencies. So there may be some packages that you actually don't want to include as part of your builds, For example, we did not want to include something like singular R, the old package, so we just toggled it off. We basically just said, hey, if you are compiling against 472, go ahead and include this, but otherwise just don't worry about it. We have another place to find our singular R dependencies, so we don't need to worry about this. And this was super useful in our product packages to basically toggle off all the packages for .NET Core 3.1 that didn't work yet, and then one by one include them in our builds as we made sure the code is also updated to function properly. And the way you can address the code, right, is by having something called preprocessor directives, which basically says you can switch off and on code based on conditions like the framework. And previously, to be completely honest, I did not like this previously because they're ugly and they make it very, very difficult to read the code sometimes. But they were super useful for this migration, and they really, really saved us in so many occasions when we need to massage our way out of code. And remember that we had to do this migration in place. So we had to release things to production every 2 weeks that still should work. So by being able to like disable certain pieces of code for .NET Core 3.1 or vice versa, and slowly kind of phase out packages and say, like, for example, singular R, right? Singular R changed a lot. We had to do a completely new implementation of it for .NET Core. But we can do that side by side by saying, hey, these namespaces or classes only compile that for .NET Core 3.1, and this only for .NET 4.7.2. And we could massage our way out of this kind of tough spot with the help of preprocessor directives. So to sum up the updates here, definitely a couple of gotchas here that I want to make you all aware of. The first one is that, a lot of packages have reached end of life and they are no longer maintained. We all love open source software, it's fantastic, but as you may know, there's a maintainer or a couple of maintainers, and once they do something else in their life, these packages may not actually continue to live on. And especially when you go to something like to a new framework version, like .NET Core 3.1 here. So we found a couple of packages that we had to phase out. We had to, we had some couple of testing frameworks we had to change. We had like Auto Mocker, thing like that, or Auto Mock was the package we had to actually change for our 20,000 unit tests because that was no longer supported. We also had a couple of email templating libraries that were no longer supported, so we had to phase out. It tends not to be a huge thing because the big libraries generally are supported, but just pay attention to this because it may be something that you want to be aware of as you do your migration. Another thing I also want to mention is the behavioral changes. So I mentioned API changes, right? Breaking changes in the API is very kind of expected, but you can also have behavioral changes. So suddenly AutoMapper works differently than it did before. And the only way to catch this is really through functional tests. So I really encourage you all to look at functional tests to catch these things. And the third thing I want to mention are assembly redirects. So as you update the .NET Framework version to 4.7.2, as you update to .NET Core, as you update dependency versions, you will suddenly understand that or see that some packages have different underlying dependencies and they require different dependencies to work. And it's something called assembly redirects, just in general an issue. But you can solve this with assembly redirects. But finding which package that works for 3-4 different dependencies is a pain. And it's really, really tough to do this. I just encourage you all to be positive and wake up with a smile every day, because that's what I try to do, and just kind of keep fighting that assembly redirect war. You will win it eventually, but it will be painful for a period of time here. All right, so moving on here, let's move on to one of the more complicated things here, which is the web app porting. So far we have changed everything in place. We basically have updated the projects that the web app depends on by updating their dependencies, updating the product structure, updating code, and so forth. But when we get to the web app here, we actually need to create a new project. You can't have the same project in place for web app. You need to create a new project with a new structure. And what you basically want to do here is you want to migrate your global exec to startup.cs class. And you want to move over controllers and namespaces to this new project. But again, I do want to stress one thing here. Please avoid a long-running branch at all costs here, because it will definitely be more beneficial for you, even though it may seem tempting to go ahead and just do that. And as you can do this migration as well, and I'll touch on this a bit later, but just make sure that you understand how your API works, because the behavior of your API changes a bit between .NET Framework and .NET Core. The .NET Core API is much more strict. So your UI may behave differently if you're not consistent in your payloads to the backend, for example. Just a very interesting observation that we ran into a couple of times here. So what kind of strategies do we have available here for doing this migration? Well, you can skip it completely and sunset the application, and hopefully you have already made a decision ahead of time. Because some applications, right, either you don't need them anymore, you sunset them, or you can want to do a complete rewrite in something else, which is also very useful for small applications. But hopefully not. You can also do big bang, long-running branches, but again, I discourage from doing that. You can also think about a side-by-side redirects. So, for example, you can move over certain domains of your application to another .NET Core web app. And you can have redirects between those applications for a longer period of time as you phase out the old application. I don't recommend this approach because I've seen it happen in other products, and what tends to happen is that you tend to deprioritize the migration. So suddenly you have both apps at the same time, and there's just no clear incentive from the business to move things over. You kind of just get stuck in between usually. So to keep the business's attention and especially funding, I don't recommend that approach. The one way we went with is something I have named incrementally with a small bang, and I trademark it to IWASD. Very funny, but yeah, it actually worked really well. So let me talk more about what I mean with incrementally with a small bang. So I sat down and thought about this problem, okay, how can we do this as incrementally as possible, with as small as impact as possible to production, and with as much safety as possible, without long-running branch. And the way I thought about it is that we have two kinds of code here. We have slow changing code that just change incrementally, and we have fast changing code that change for every feature that can happen. We just don't know if anything's going to change. And I want to have a different approach for each of these. So for the slow changing code, this stuff like infrastructure, like autofac, automopper, authorization, authentication, and filters, all those things, right? All the piping that you never really change, but it's there. So the approach we took here is that, hey, let's create a project for .NET Core. Let's create tickets for each of these major infrastructure piping, and let's move over them one by one during each sprint, because like that, they will be in a new project, they will be compatible, and we don't run the risk of actually having to change them because they change very rarely. But it will all be in the master branch, which is great. So that's what we did actually. We went ahead and changed all these things into new .NET Core projects, and we made sure that it functioned by testing authentication, and we tested DI setup and all those kind of stuff. So suddenly we had this nice parallel .NET Framework .NET Core application that we did not put in production, but that was fully functioning locally with all of the dependencies. And then what we went ahead and did was, let's look at all the other code, all the fast changing code that can change by any change from a feature in a sprint. So for example, controller and view models and all this stuff. So we couldn't just migrate that over bit by bit, because suddenly we had a controller of the same type in different projects, and we have to keep them up to date between sprints, and it was just a nightmare. So we did not want to do that. So what we did instead is we created a console application that would, a tool basically, that would convert these on demand. And I call it the third branch instead. So I created a little thing here to indicate how this works. But basically what we had here is we had a .NET Core console application, which is basically ended up being 300 lines long. And what it did is it went through all of the web app, and it replaced namespaces, it replaced usings, it replaced different common things from .NET Framework to .NET Core that was the same overall. And it did also change a couple of files very specifically, where we had specific implementations that were very custom to our application. But basically, what we can do is we can run this tool on the master branch, and it would spit out a .NET Core fully functioning application. And if it did not spit out a fully functional application, then we can learn something from that. We could compile the application, and we can see, okay, what's the build errors? Is this something we can change in the master branch that will work for both .NET Core, .NET Framework? If yes, for example, consolidations, then let's create a ticket for that and put that in the sprint and just do that. If no, if it's very specific for .NET Core, like a very specific thing, let's put that into the tool so the tool knows how to convert that next time. And then we iterate over this over and over and over again until we finally had a branch that actually compiled in .NET Core for the web app and that actually ran on our local machine. And once we had that, we could hit it with all our automated UI tests, hit it with all our functional API tests and everything else, and make sure that fully function. We can even actually put a new pipeline in our DevOps pipelines here and deploy it to a separate environment for testing from our quality team or quality members. And they could hit it with all their kind of automated tests and manual tests as well. And after a while, we got to a point, of course, where, hey, we're very confident that every time we use this tool to convert application, it will spit out the functioning application. We are in a very good state here. And once we're in a good state, then we can actually get the buy-in from the business saying, hey, we think we're ready with this migration. We have application that we can convert and deploy to production whenever you want to. And the business can then schedule this deployment whenever they want to and say, yeah, that makes it great, that's great. Let's go ahead and merge this to master and get it deployed to production whenever it works for us. So this was a very useful approach for us to reduce the risk and make sure the business felt heard. So the final piece I want to mention is to update your CI/CD portion here. And it's super simple things, really. You will have been using MS Build for most of your time if you're on .NET Framework, and you want to go to the CLI instead, the .NET CLI, which is basically just .NET Build, .NET Test, .NET Publish. So that's going to just make things much easier for you than anything else, and it's actually much easier to create your CI steps here. The thing I want to mention is that if you are like us, staying on EF6.4, as you move on to .NET Core, which is fully functional and possible, just kind of have a look at your migration strategy if you're using code-first migrations, because it's a little trickier to run your migrations. It's not as straightforward. You can't use the migrate.exe anymore. You have to use something called ef6.dll. And you have to do some PowerShell scripting to get this working properly, because you have to use the .NET executable to do this. There's really no documentation for this because Microsoft does not want you officially to be in this limbo state for too long, but it's possible. So if you end up in this stage and you have problems doing this, reach out to me on LinkedIn or Twitter. I have some PowerShell scripts I can give you that will help you through these steps more easily. So to sum up the presentation, before we kind of jump into any questions you may have to me, I wanted to touch on things that we learned through this migration effort. And the first thing I want to mention is that unit tests are not very helpful. We had a very mature team in the sense that they had tons of tests. We have 20,000 unit tests, 3,000 functional API tests, I think 1,000 functional UI tests, and so forth that we ran all the time. But unit tests were kind of pointless because unit tests tested like the logic, but doesn't test integrations, doesn't test, of course, package updates and so forth. So it wasn't very helpful. But we realized that functional tests are super helpful. Like we leaned on our API test and UI test all the time because they really caught things like assembly redirect issues that happens during runtime and other things like that. So that was very helpful. We also found that pre-processor directives really saved the day for us. If you're doing something in place like we did, without them, I think it would have been impossible for us to do it. So definitely embrace them if you're doing an in-place replacement, and it will make your life much easier. Also, I strongly recommend not going to EF Core directly. It's not necessarily updating a package here, it's porting your whole Entity Framework implementation to something else. So it's just too many breaking API changes to be comfortable doing that at the same time, or you get stuck for a very long time doing this upgrade for a large application. Also, I also consider stay on IIS. We are staying on IIS right now, and then we'll go to Kestrel, which is awesome. But don't take on too much at the same time. You can still run your application IIS on .NET Core. It's fully functional and actually really fast. And then you can have a separate effort to go to Kestrel or microservices or whatever you want to do, but just don't take on everything at the same time. It's just too much. My takeaway from this is that the hardest part for us was definitely getting the web app up and running on the latest stuff. That was definitely the most complicated thing that we did. and something that you would definitely need to allocate enough time for and resources as you do that. And the final thing I want to mention is that, again, the API behavior changed a lot. .NET Core is much more strict. We had some really poor architecture on our REST API and some really poor client code that call API with not fully functional payloads of different sorts. And it definitely hurt us a lot. We had tons of places where we had we suddenly couldn't find the resource anymore, or the payload was incorrect or not validated by .NET Core, just because .NET Core is much more strict. I personally loved it. It was great. We found all this old technical depth that we had to fix, but not everyone will be so happy. And you definitely just want to make sure you think about that as you kind of move forward. But if you have functional test or API test or UI test, you will find these things. So it's just a matter of fixing them for you. So with that, we have some minutes left here, about 9 minutes left. And I want to make sure I had enough time for any questions you may have. Realizing here there's a little delay here between when I see your questions and when you ask them. So I will kind of stop talking a bit and give you a moment here to ask any questions. And I see I have one question here from Marcin here. So I will start by answering that question as I wait for other questions here. So the question here is, have you done any performance testing before and after migration? And can you share how those compare? And that's a great question, Marcin. We did actually do some performance testing before and some after. And for our application as a whole, the web API, we had, I think, 28% or something around that percent increase in performance. It was a lot faster. It was noticeably faster for us. And we didn't do any active change. We didn't try to improve performance. We just updated the framework to .NET Core, and they gave us 28% bump. We had a team that we depend on that does a lot of calculations for our application, and they used heavily used Automapper and some older stuff like that, and they both updated to the new framework to .NET Core, as well as did the Automapper remap completely refactor, and they had a 70% increase in performance from that. So that was just insane. But I think that was very specific for them. But I think you can assume, I think from what I read as well, 25 to 30% is kind of what you expect. And then you can get other 10%, I think, if you go to .NET 5, which is even faster, especially if you start doing a lot of text manipulations and string manipulations. But yeah, that's a great question. Thank you, Marcin. I hope that answered your question. So if you have any other questions, feel free to put them in the Q&A. I'll be on for a little bit longer here and wait for your questions. And I'll go back and put a slide up here as well for my contact details. I don't know if I have them actually. While I wait for that. So if you have any questions, you can of course reach me on LinkedIn. You can just search my name, Alexander Slotte. You will find me there. You can also find me on Twitter at Alex Slotte. I will be happy to connect you with there as well. I mostly tweet about machine learning.net stuff with Emma.net, which is awesome too. But if you are curious about that, definitely check me out there. But yeah, more than happy to connect in either way here. So I think we wrapped up with questions, but I just want to take a second here to thank you all for joining this session a lot. I know you probably had a great time in Vilnius. I wish I could be there in person, but hopefully I will be there next year for this conference, which is an awesome conference. So I hope you have a fantastic rest of the conference, and thank you very much for joining my session. Have a good rest of your day. Bye-bye.